The second classic form of Mendelian inheritance is autosomal recessive inheritance, where a faulty copy of the gene is inherited from both parents. Selina, Dominic, thanks for coming. My name's John Byrne. I'm a consultant in clinical genetics, and I've been asked to have a chat with you because of the problems with the baby that you lost. Can I ask what the baby was called?
David.
And how long is it now since David died?
6 weeks.
Okay. The team that looked after David sent some samples in to us and also did several investigations, and we know that we know the cause for that now. So what I'd like to do is explain to you why David died, and then answer any questions that you might have. But before I do explain, can I ask what questions do you think you might like an answer to?
Well, firstly, obviously, why and how, and if there was anything we could have done to prevent it, and secondly, will it happen again?
Yeah, sure. Okay. Well, first of all, let me explain what it was that David had. David had a condition called spinal muscular atrophy, and that means that the little nerve cells in his spinal cord, which drive the muscles, stopped working. Now, we all make these little relay stations down our back so that the messages from our brain can get out to our muscles. And as we're developing in the womb, most of the cells die away, leaving just these key cells to act as relay stations. Because of the spelling mistake in the gene, David didn't keep the relay stations, so those cells died away, and that made him very weak because he couldn't move his muscles properly. And in fact, sometimes children live quite a long time, but he got a chest infection because of his inability to cough and move his muscles, and that's led to his infectious, very severe infection, and that led to him dying. Now, we know the cause of this because it's a very well recognised diagnosis. It's what we call an autosomal recessive trait. Now, just to explain that in a little bit more detail, we all carry our genes in matching pairs with a copy from mum and a copy from dad, and it works out that every one of us has at least one gene that's got a spelling mistake in it, but usually we get by on the spare copy, so we never know. But now and again a couple will marry who both carry the same spelling mistake in the same gene, or at least a spelling mistake in the same gene that stops one copy working. So that's what's happened in your case. So in each of you have one working copy of this gene, which is fine, and the other one which has a spelling mistake in it. And each time you have a pregnancy, it's a 50-50 chance whether you pass on the working copy of the gene or the one with the spelling mistake. So there's a 50-50 chance that the egg will get the faulty copy of the gene, and there's a 50-50 chance that it will meet a sperm that also has the faulty copy of the gene. So each time you get pregnant, there's a half chance of it coming in the egg and a half chance of it coming in the sperm. So there's a quarter chance, a 1 in 4 chance, that you'll end up with 2 faulty copies of the gene, and then the baby will have the same problem.
That's just for the spinal thing. That's
just for spinal muscular atrophy. Otherwise, you're just the same as everybody else.
But we could have a faulty one from Dom and a healthy one from me, absolutely, or vice versa, and the baby would be fine.
That's right. So in fact, the good news is that in fact there's a 3 out of 4 chance that one of you or both of you will give a working copy of the gene, and the baby will be fine.
Mm-hmm.
Now we do know, and you asked whether it would happen again. The answer is it's a 1 in 4 risk. The next natural question from that is, well, would it be the same? Would it be as bad? And the answer is it always is a pretty bad condition. If you've got the full-blown disorder, it'd be very unlikely that the baby would survive long term if you had another baby that was affected.
So if it hadn't been that infection that killed him, it would have been something.
It would have
else.
Just been failure of the respiratory system, and the baby just would have, David would just gradually become weaker and unable to breathe.
But it's possible that the baby could go to full term and be born and then die in early life.
Yeah. Now, the good news is that we actually know from the tests that were sent in what the precise spelling mistake was. So this is something that we can test a future pregnancy for. So when you get pregnant, we could bring you in at 11 weeks and take a sample from the afterbirth to see whether the pregnancy is affected or not. And then that gives you the chance of termination of that pregnancy. You don't have to. You might just say, well, we'd like to know, but I wouldn't want a termination. That's a decision you can take yourselves. But the important thing is that option exists, and that's something that you might want to talk about. A lot of people use diagrams when they're explaining single gene inheritance. I prefer to use my hands for the simple reason that I can carry on looking at people. If I'm using my hands in this way, I'm watching their reaction, and people sometimes don't understand, and you can do it again. If you start drawing diagrams, you're not looking at them, and therefore you don't get that feedback.